Hello everyone, I'm Dr. Jenny. Today I'm going to explain to you a real baccalaureate questions in 2013. This is a complex number question. That is question B5. So I'm going to copy this question again. Give the solution to the equation z to the power of 5 equal to minus 4 times square root of 2. So this is a question to look for the roots of a complex number. So because we see the exponential is to the power of 5, we know that there must be 5 roots exist. So they will be namely z1, z2, z3 until z5. So the way to solve for the roots of a complex number is always we're gonna change that complex number, so the results, to the exponential form. So by saying exponential form, it's normally the Euler's form, which is r times e to the power of theta I. R is the magnitude, so how long the complex number is, and theta is the argument. So that is the angle. So what we are going to do now is we are actually going to plot the result on an Argand diagram. So the x-axis will be the real axis. Yeah, for the r, and the y-axis is the imaginary axis. Okay, so our result is actually minus 4 times square root of 2. So this is a real number because we don't see I inside. Therefore, we're going to plot it on the real axis. So let's say it is here, minus 4 times square root of 2. Okay, so it doesn't have any I inside, so therefore the imaginary part is 0. Okay, we're going to draw an arrow from origin to this point, and then we can see the argument is from the positive side of x-axis, so we go all the way here, and that is 180 degrees or pi. We normally would use the radians, which is the pi. So the distance between the origin and this point will just be 4 square root of 2. So the magnitude is always positive. Okay, so now we have successfully transferred this number into exponential form or the Euler's form. First of all, the r, we are going to write the magnitude of this and then times e to the power of pi I. Okay, so the next step is we're going to do the roots of this, but before we're going to do that, we're just going to add one thing, which is 2k pi. Okay, so where we're gonna add the 2k pi is just exactly next to pi. We're gonna add 2k pi plus pi, and then we put everything in brackets, and then we put I. So this doesn't change the value of this complex number because 2k pi, it would be like 1 circle is 2 pi, 2 circle is 4 pi, 3 circle, that's gonna be 6 pi. So no matter how many circles you're gonna add, you see, you always end up to be in the same direction, right? So it doesn't change the direction of the complex number. Okay, so next step, what we're going to do is to get z. So therefore z equals to, now we are going to put this exponential 5 to the other side of the equal sign, and then it will become 1 over 5, yeah, to the power of 1 over 5. So I'm going to copy all this to here. Okay. So after I copy that, I'm just going to put everything in the bracket and put 1 over 5 to this side. So in math, it's always like this. When you have a z plus 1 on the left-hand side of the equal sign, if you want to put that to the right-hand side, it will become z equals to minus 5, yeah? So z plus 5, if you put plus 5 on the right-hand side, it becomes minus 5. And then if you do z to the power of 5, and if you want to put the 5 into the other side, so we're going to think reversely. To the power of 5, the reverse part will just be to the power of 1 over 5. Okay, so after we've done that, we're going to distribute the 1 over 5 to this part, so the magnitude part, and the exponential part. And that will give us 4 times root 2, 1 over 5 exponential, and then e to k pi plus pi times I multiplied by 1 over 5. So you see, 1 over 5, once it goes to 2 root 4 root 2, you will get 1 over 5 as an exponential. But if you are distributing 1 over 5 to e to the power of this, it will become multiply because this part is already exponential. So what we're doing is simply multiply that to the exponential of e. Okay. Okay. So for square root of 2 to the power of 1 over 5, you can also write it down in this kind of format if you prefer. Okay. Now we're going to separate 4 times root 2 into 5 things. So what you would have is root 2 times root 2 times root 2 times root 2 times 2. Okay. Okay. So in this case, you will see 5 root 2 inside. And why these things are equal to each other is because root 2 times root 2, that is 2. Root 2 times root 2, that is 2, right? And 2 times 2, that is 4. And then if you then multiply by the fifth things, which is root 2, then you will have 4 times root 2. Okay. Okay, here I'm going to just delete all that and directly write root 2, because if you have 5 root 2 inside the root, then you can just take 1 out. Okay. And then we're going to drop that part down. Multiply by 1 over 5. You can combine these two and directly say over 5. Okay, until now, we have done the first part. The second part, what we are going to do is let k equals to 0, 1, 2, 3, 4. Because there are 5 roots, that is what we are expecting, because it's z to the power of 5. So we are expecting 5 roots. So I'm going to write 5 possibilities. So k equals to that, and until 4. Okay, so when k equals to 0, we will get Z1. We'll call it Z1. Will equal to square root of 2 times E, and then 2 times 0 times pi, plus pi times I over 5. Okay, so the part with 0 goes away because it's just 0. And then what you would have will just be root 2 times E. And then what you have is this pi left with that I. So pi over 5 times I. That is your first root. Okay? We're going to follow the same thing to find root 2. In this case, you're just going to replace k by 1. Okay, everything else remains the same. Okay. Okay, so that's gonna equal to, so 2 pi plus pi will be 3 pi over 5. Okay, E is here, times I. Okay, so we're just gonna repeat this operation until we get 5 of the roots. So this time is 2 times pi, 5 over 5, bracket times I. So what you have here will just be 4 pi plus pi, and that will be 5. So you would have 5 pi over 5 times I. So in this case, you can cross this 5 on top and then on the bottom away. You will just have pi I. Okay, so now we are going to do the fourth one. So again, replace the k by this k value, which is 3. So we're going to put 3 here. Copy the rest. Okay. And in this case, 2 times 3 is 6. 6 plus 1 is 7. So together you get 7 pi over 5 I in the end. Okay. So almost done. Last one. That's 5. Root 2 times E, 2 times 4 times pi plus pi, bracket. Don't forget about the brackets. It's very important because otherwise you're going to change the order of the calculation. So 2 times 4 will be 8. 8 plus pi, you will get 9. Okay, very good. So now if you look at these 5 values, yeah, those are the 5 answers you're going to have for this first question, yeah? So you have given the solutions to the equation in the form, in the Euler's form, yeah? So you have all these 5 solutions ready. Okay, so now let's look at question B. Represent the solutions in the complex plane. So that is usually quite easy. Question B, we are first going to draw a complex plane. Okay, let's look at Z1. Z1 equals to root 2 times E to the power of pi over 5 times I. So in this case, the argument is pi over 5. Yeah, and the magnitude is root 2. So in fact, if you check these 5 roots, their magnitudes are always the same. They are always root 2. Okay, so what we are going to do now, we actually just draw a circle with a radius of root 2. on this argon diagram. So looks like this. This will just give us a guidance of the magnitude, because like this, no matter where I draw the complex number, as long as it falls on the circumference of this circle, we know that the magnitude will be √2, because all the points on this circle have the same distance to the origin. Okay, now we are going to look at the arguments of the first root, which is pi over 5. So pi over 5, you can either calculate it by heart or use a calculator. So what you would have is, well, pi over 5, that is, you're going to chop pi into 5 parts, right? It's like dividing a cake. So pi, you know that it's half of a circle, yeah? This part is pi. And if you chop that into 5 parts, then you approximately, okay, chop it here and here and here. And okay, get to this side. Okay, so like this, you chopped pi into 5 parts. So this is 1 part, this is 2 part, 3 part, 4 part, 5 parts.